Wave interference is also known as superposition. And essentially what wave interference is just showing what happens when you have two waves interact with each other. Because waves are the propagation of energy, waves can and do very often interact with each other. But because waves are actually just the propagation of energy and not particles themselves, the waves pass through each other. But during the passing of the waves through each other, you can have different results occur depending on how the waves actually interact and depending on the nature of the waves themselves. So I just want to give you a couple of examples of wave interference. Let's take a look at a couple of superposition patterns. Now the first one I want to show you is if we have a wave, let's just say that this is a wave where it's just triangular in nature, and we have another wave here that is also triangular nature. Let's just say that the one is moving to the right, the other is moving to the left. What happens is the energies actually combine when they go through each other. So if we just show what happens then, if this is the first one, the second one is going to be in the exact same spot as the first one, which means they're actually going to add up. They're going to combine. So the heights end up being double what they were. So if you were to actually look at this on the side, you'd actually see a wave that looks like that, just the one in the red. You wouldn't see the two small ones in the blue, you'd actually see the bigger one in the red. This is called constructive interference. And the reason why it's called constructive interference is because both waves are on the same side of our medium, and because of that, they're going to add together. They're going to construct a larger wave. The other wave that we could have isn't constructive, is actually destructive interference. And for that to occur, let's just say we have our two triangular waves, but this time, let's just say that they are on opposite sides of the medium. When this wave is moving to the right and this wave is moving to the left, when they actually are overlapping with each other, the one wave that's originally on the left is going to still be on top. This wave on the right is going to be on the bottom. And when these two actually interact with each other, if you add up the heights, you're adding a positive to a negative value, since the heights are identical, positive 1, negative 1, positive 1/2, negative 1/2, positive 1/2, negative 1/2, they cancel each other out on all the spots. And what you end up seeing is no wave at all. So if you were to actually look at these two waves, you'd actually see just a flat line. At this particular spot, it would look like that wave doesn't even exist, even though they're both still there. The energy from both waves still exists, it's just at this moment they're canceling each other out. But as time goes on, what's going to end up happening is you will see these waves just continue on. So it's just for a brief moment. They don't actually destroy each other, but for a brief moment it looks like they're not there, then they just continue on their merry way. This is called destructive then. It's destructive interference because they are destroying each other. Now, as we go through and look at some different examples in class and also another video I'm going to have for you, not all the waves are going to look exactly like this. They're not all going to be perfect triangles or perfect squares, and in fact, they won't be exactly identical to each other in terms of the shape. So you might have, let's say, a square here and a triangle over here, and so we're going to have to look and see what happens in those different cases, but it's all basically the same. You're just adding up the heights at the particular spots. So as we go through some examples, I'm sure you will see and get used to how to handle this wave interference, also known as superposition.